All right. Morning, everyone. My name is Miguel Araújo, and we're going to talk about MySQL Architectures, so where we support to ensure business continuity, and mostly MySQL Shell, which is what I do at Oracle. So my name is Miguel. I'm from Portugal. I joined MySQL back in 2011, in November, and a bit before that, just to give you some historical background, I was working on some research. I was doing some research, and I wanted to improve the current replication mechanism in MySQL. That was just master-slave classic asynchronous replication, and I wanted to do something using group communication primitives to have total order and so on. So I was hacking and prototyping things, and I came across the MySQL proxy. That was a layer 7 proxy, and it had understanding of the MySQL protocol. It was pluggable. It had these Lua scripts that you could change the configuration and so on. And I also came across the spread toolkit. That was an implementation of a group application. So I joined everything together with proxy, and I also extended proxy to understand bin logs and to use this group communication system. And I was just hacking around in prototype things, and I was annoying Jan Neschke, that was the developer of MySQL proxy on Freenode on IRC, asked tons of questions, and at some point they were like, what the hell are you doing? And a bit after, they reached out to me and said, hey, we're hiring, we need someone to work on proxy, want to join? So that's how I started. I've worked at MySQL proxy for a couple of years, but it didn't reach GA quality. I don't know if that's my fault or not. It was abandoned, and while that was going on, MySQL Fabric came out as the first GA. I don't know if you know Fabric, or I don't know if anyone use Fabric here?
Use it. I know about it, but use it.
Well, okay. Yeah, I'm going to not talk about that. So Fabric was aimed to help with high availability based on the current replication solution, and it did something that some years after Orchestrated did. It was auto failover, switch over. It was meant to help with these kind of things, and also sharding at the same time. So yeah, it was complicated. A bit after came out the first Hello World blog post from Luis announcing group replication. That was a game changer. You all know group replication, so no need to introduce that. And a bit after, MySQL Router was born, and MySQL Router came out as a solution to the problem of every connector having to implement the logic to handle MySQL Fabric. So we wanted to strip that out of the connectors, put it in a single place. So Router came out as a solution for that, to like an extension of a connector, a very simple middleware, just a TCP forwarder, and it will understand the Fabric logic. So yeah, MySQL Fabric aimed for perfection instead of actually getting things done, and it solved complex problems, but it didn't solve basic things such as, it was a single point of failure. It was really hard to use. It was awful. My experience was really bad. So yeah, it didn't have much adoption, to be honest. And a bit after, I joined a new team. We were creating a new protocol, the DocStore, the XDevAPI, and with that came out the need for a new client that would support this new DocStore API, and with support in both Python and JavaScript. So we created MySQL Shell from scratch, a new client line tool, you know it. And MySQL started as this new client tool with support for SQL, Python, and JavaScript, and with the classic protocol and the XDevAPI supported there as well. The first preview release was 2016. And while this was going on, group application was getting more mature. And we understood and we realized that we needed something that was easy to use, and we wanted to provide a fully integrated solution for group application and asynchronous replication. And with the errors from the past, we learned that usability was really important. So we came up with the idea of creating an API in MySQL Shell to help deploy this kind of topologies, and also to create this metadata scheme and so on. So MySQL Router came into play to do the transparent routing of queries and understand this kind of topologies. So in 2016, I started designing and implementing the AdminAPI in MySQL Shell. It came out as a preview release, and then in 17, group application was GA and Shell and Router GA as well. And I did a live demo in FOSDEM back then. It was great success. People really liked it. So, sorry, I don't want to bore you with historical lessons, but I think it's nice to understand how projects are born and just requirements don't fall out of the sky. So, going back to MySQL architectures, just recap, you should all know these kind of things. Concepts when you think about deploying an architecture, RTO and RPO, RTO recovery time objective, so how long does it take to recover from a failure, and how much data you are willing to lose when a failure occurs. Types of failures, single server failure, network partition, you need high availability for that, disaster recovery, full region outage, and human error, maybe artificial intelligence will solve that out for us. So the current architectures that we support, just a summary, there's no need to go into detail, this is a widely spoken topic. Replica set is the classic asynchronous replication-based solution. It's asynchronously, so has better write performance. You need to do manual failover and switch over. So RPO, it's not zero because the system is asynchronous and a replica might not have applied all the data yet. So when the primary is gone and you promote the replica to be the secondary to be the new primary, some data can be lost. And RTO is minutes or more because you need to do manual failover. InnoDB cluster, our flagship solution based on group application, so you have auto failover, consistency and so on, network partitioning handling, very important, and no data loss, and the recovery time objective is seconds because you get automatic failover. 2 years ago, in 8.0.27, if I recall correctly, we came out with this new solution for disaster tolerance. So we called it cluster sets because these are sets of clusters. They are connected through an asynchronous channel. This asynchronous channel that is over there has this auto failover built-in feature. So when the source of the channel is gone, in this case the primary, and a new one is selected, the channel will automatically reconnect to the new primary and ensure that the replication flow keeps ongoing. And the same thing on the other endpoint. If the source, the replica is gone, there will be a reconnection of a new channel. So you get high availability within a region because they are InnoDB clusters, and you get disaster recovery. If the full region fails, you can promote a replica cluster to be the new primary.
But there's no cross-region HA?
No, not yet.
Unless you do GRO cross regions?
Yes. Do I go back? Okay. This is the latest addition to the stack. In 8.1, we introduced read replicas, so the solution for read scale out. You can add any amount of replicas to a cluster. There's no limitation, just physical limitations. You can choose whether you want replicas to replicate from the primary or from secondary. Replicas are using that same asynchronous channel with the auto failover. So if you add a replica that is connected to the primary and the primary is gone and a new one is elected, the replica will reconnect to the new primary. You can choose whether you want to failover from the primary, failover from always the secondary, or even you can choose a list of candidates for the replica. This is fully supported on cluster and cluster set. It's very flexible. You can add, remove replicas online. You can take out the replica and promote it to be a member of the group, or the other way around. You can configure router behavior dynamically through Shell. I will talk about it a bit later. So you can choose where to route traffic. The red arrows here are the read-write traffic, and the green ones read-only traffic. You can choose whether you want router to use only the replica cluster, follow the primary, use only read replicas for read-only traffic, and so on.
Can you have multiple replica sets on the same cluster? Because for different workloads, you may not want to mix the same service bit traffic because the workloads are different, and therefore have multiple replica sets underneath the cluster.
These mean cluster sets.
Yes.
Not replica set, cluster set.
The async replicas, not the async replicas.
Replica set is classic asynchronous replication.
Yeah, but do you allow multiple of them to run independently? You can do that.
Yeah. So yeah, this is the list of solutions we support at the moment. Just a quick recap of business requirements and which architecture is the best for your problem. High availability within a single region in a cluster has automatic failover. If you need better write performance, you can use replica set because it's asynchronous, so has better write performance. However, you're going to have to live with the manual failover. Like someone was saying, you can deploy a cluster across multiple regions. You need a very stable network, otherwise group replication will get unstable and there will be suspicions that members are not responding. They can be evicted from the cluster, so the solution is tough, not really recommended. For multi-region, the linear cluster set is the way to go. And finally, read replicas, the solution for read scale out. If you want to offload primaries or secondaries from read traffic, you can have read replicas and scale out, and this is good for read intensive workloads. Yes?
Are you planning on adding multiple levels of replication for replica sets?
Yes. At the moment, it's not supported. You can also add replicas for other purposes, for example, reporting, or any other. Is this complex? Well, for many of you, probably not, but for a lot of people it is. And what you learn and what people really want is something that is easy to deploy, easy to maintain, and easy to monitor. And that's why the AdminAPI was developed. And just to show you how easy it is, many of you are already familiar with this. So with just some very simple and intuitive commands, you deploy a topology. In this case, this is I don't know how much. This is the deployment of a replica set. We have commands to configure the instances. So if you just install MySQL and you didn't change anything there, the shell can do the configuration for you to ensure the instance will be ready to be used in the topology. And then you create the topology. You can set up admin accounts in case you don't want to use your own. You can instruct shell to create an account with a the right set of privileges, the minimum set of privileges needed to administrate a topology, and then you add instances with that instance. This includes integrated provisioning. We use MySQL clone or binlog-based replication to provision instances. Shell will guide you through the process. And so on. Same for cluster, same look and feel, very easy to deploy. Replica set, the same story. You create cluster set. You create a cluster set from a standalone cluster. We create cluster set. That's just registering in the metadata that this is going to become a cluster set. Then you create a replica cluster out of a single instance. Shell will connect to the instance, will create the topology there, will start the asynchronous channel, will do configuration, and you got this new cluster replicating from the primary cluster, and then in that cluster you can add instances like it was just a regular cluster. Read replicas, same story. We called it add replica instance instead of add instance. You can configure router behavior dynamically. I'll go into that next. And you can also configure, I will show you how to configure the replicas for your needs. So in general, the AdminAPI has evolved, and in terms of features, we have sandbox management to create sandboxes and play around and test things. The configuration checker and applier that was mentioned before, account management, the support to manage all this kind of MySQL architectures, integrated provisioning, configuration management to change group replication options, other replication options, for example, MySQL router management, and we follow best practices. This means, for example, we're using by default MySQL from stack, We have parallel appliers enabled and so on. Many of those things are default now in replication and group replication, but they weren't, and we started using them by default in Shell first. Just side note, Shell is just it's not just a bunch of scripts like a lot of people say. It's almost 80K lines of C++ code and some SQL too, and it took some time to develop, also a very small team. And yeah, you need to support, we support from 5.7 until 8.3, the latest. So hybrid setups and try to protect users from doing mistakes and so on. So it's not that simple. The latest additions, regarding security, we're using the MySQL ComStack by default. This is great because you don't need to use whitelists anymore or have a specific ports for group communication. So we use it by default. We have now full SSL support. Using the AdminAPI, you can encrypt group replication and asynchronous replication channels. And the great thing is that you can use now passwordless authentication for the internal communication and also for the router and admin accounts. So you can set up your full topology to use certificates. This is just an example of creating a cluster using SSL mode verify identity and passing the certificates, the issuer and the subject, and the command will check, it will do a connectivity check to see if the SSL configuration is correct, and we'll create the topology using that. This is not that important, but it's funny, we saw some customers and users coming back with some weird scenarios on that the metadata was in a weird state, and we realized that there were multiple people operating on the same topology at the same time. And we weren't expecting that, but we introduced this locking mechanism to prevent conflicting operations to run concurrently. So this is supported on all API. Some commands have a shared lock, some have an exclusive lock. Another more interesting thing is the rollback. We have rollback for the operations. So if a command is executing and if for some reason fails while in the middle of the operation, we will roll back everything so we don't leave the instance, the target server in this transit state with some configuration supply, some internal replication accounts there. We roll back everything. Yeah.
Yeah. So for the looking risk, we have noticed sometimes that there are some leftover state logs that block any future changes.
Sorry, I don't understand the
state logs that stay there for a few days and blocking changes.
In which version?
34.
Okay, because there were some bugs that were fixed after that.
Reported that.
Okay, that's fixed already.
Okay.
So it's fixed. Which version has to fix?
36, I guess.
Probably, yeah. I don't remember. But you should always use latest shell version.
So we should be using A3.
Right, but these are locks like in the GR cluster, not in the shell.
In the server, we use the locking.
Yeah, okay, it's in the server, but
Yeah.
it needs upgrades. Are the locks set by the shell or by the server?
By the shell.
So it's leftover locks are a problem in the shell, not a problem in the server.
Yes.
Okay, thank you.
Yes.
Right. Right.
Yeah, some questions?
Compatibility of MySQL Shell between will MySQL Shell 8.4 works with 8.0 MySQL.
Yes.
So I can manage
8.4.
8.0 till 8.4.
Yes. Always use the latest. The only thing 8.4 will not support is 5.7.
Yeah.
Because 5.7 is EOL since October last year.
What about router? Will MySQL router 8.4 works with all versions
Yes.
still 8.0?
Yes.
Okay.
So you should always use latest router and shell. Yeah.
Yeah, just a question about the locking mechanism. So you are locking data specific to MySQL Shell, or you are locking the data?
Yes, we're locking the metadata.
Okay.
That is the most important thing. Okay, next. Router management. You can configure router through Shell. One individual router or the whole set of routers of your topology. Right now, we don't support the full set of router configurations. The things we support are mostly related with MySQL architectures. So, for example, here, control our router should behave with read replicas. So, read-only traffic should go to all the members of the cluster, to read replicas only, or just to the secondaries. You can do this through Shell and some other things. I'm actively working with the router folks, designing a new way to handle this, and our goal is to make router fully configurable through Shell. So you don't have to go connect to each router and change the configuration of that. This is an example of the built-in help system in Shell. You can, if you want to access the information about each command, just do /?, and this is just showing the set routing options with the available options to configure router. Regarding architectures, support for read replicas in 8.1, some new commands for replica set in 8.3, dissolve, describe and rescan, and we have now support for fine-grained replication options. A couple of weeks ago, someone was asking on Slack, the community one, if they could set the source spine or some other option, I don't remember, for the cluster set asynchronous channel. And back then you could do it manual, but you could also break things. And now we have support for that in Shell, so you don't have to worry for that. For all the source options and network namespace. And you can do that for the cluster set asynchronous channel and also replica set. Regarding read replicas, these are how the commands look like. To add a replica instance, it's the same as adding an instance to a cluster. By default, we'll replicate from the primary and we'll follow the primary, meaning if the primary is gone, it will autofill over to the new primary. You can change that when you create the read replica, or you can change it later at any point in time using the set instance option. You can change the replication sources and you can say, hey, please use always a secondary. So that will happen in the next failover. And if you wanted to apply that immediately, you use rejoin instance and the channel will be adjusted. And set routing option is just an example of changing the read targets of router to use only read replicas. In 8.2, we did some deprecations, 5.7, like I was saying, it's ULs, and a couple of commands that are useless, and some options that also became useless over time. And yeah, that's it.
So one thing you didn't mention, anyone that's configuring stuff with the shell by hand, I mean, you sort of mentioned to me, but doing it by hand is not good, but if you've got automation that wants to talk to the shell, you said that there's now be a way to basically have an API interface so you can actually...
That's the goal, yeah. It's still not there yet.
It's not there, but there's a plan to do that.
That's
so that we can just do an endpoint and just for on each box or something, and we can say, spin up this, do that, do whatever, and all the things you're doing manually, we can just remotely...
I think you like that.
Yeah, that'd be really useful.
Okay. Any suggestions or requests? Questions?
Just we have a question. When you have read replicas, you have any form of defining affinity or to where they want to replicate?
No, you can do that. You can choose. I mentioned before. You can say to replicate always from the primary, or always from a secondary, or even a list of.
Or for the location.
The location, not yet, but that's also part of the plan.
And even if you provide some books that we can give you the answer somehow.
Yes.
Because you never know how or no.
Exactly.
Everyone's got different architecture,
Exactly.
magic.
Yeah. Yeah. Exactly.
That would be really useful.
Yeah. Yeah.
I think you said right away on the relevant application. Can we do like the same for async application? Like I prefer to read from my secondary that is by DC rather than US.
I will talk about router in the afternoon, so let's.